Okay, if we had a picture in front of us and we wanted to find the slope, remember we could just count the rise over the run. If we don't have a picture, that's when we're going to be using this formula. Remember, M stands for the slope. So remember, the first thing we should probably do is label that X comes first in an order pair, then Y. And then remember, it doesn't really matter which one you call point 1 and which one you call point 2. I usually call the one that comes first in the sentence point 1 and the second one point 2. So then you're just going to fill things into this formula. We have Y2, that's 5.3, minus, the formula says, Y1, which is -9. So you're going to have a minus and a negative sign in there. It's all divided by x2, so -4 minus, the formula says, x1, which is 2.5. Now, again, if you had called this point 1 and this point 2, that's okay, but that means you would have these flip-flopped, but you would also have these flip-flopped. So you would end up getting the same answer. We'll talk about why in a second. So 5.3 minus -9. You could even make that into 5.3 plus 9 if you want. You're going to get, or just type the minus and the negative in your calculator, but you should have gotten 14.3 for that part. And then down here, -4 minus 2.5, we should get -6.5. So you should have 14.3. We're going to actually divide it by -6.5. Now, again, if you had this flipped around, you'd have -14.3, but you'd have this flipped around too, so it'd be +6.5. So the reason we're still going to get the same answer, let's go to our calculator, is if we do a positive divided by a negative, that's the same thing as a negative divided by a positive. That's why it doesn't matter which one you call point 1 and which one you call point 2. We don't usually write slope as a decimal, though. So if we get a decimal, even if it's a nice decimal, we should math bracket. So -11/5. Remember, if we did have a picture, this would mean rise over run, right? Like if we had a picture of 2 points, it means it's going down 11 and right 5 to make your line, okay? Any questions on that example at all? Again, that will be on your quiz that's coming up soon. All right, our next lesson, we're going to be learning about something called direct variation. So before we do that, I'm going to give you a little introduction here. So the question says, write a rule for each function and find the missing value. So notice there's one missing at the end. We'll worry about that in a second. When we have to write a rule, we want to kind of look for patterns. So when you look at this table on the left here, I want you to tell me anything you notice about it at all. Specifically, like what can I do to X to get Y? Do you see any patterns at all here about what is happening? Eli? Yeah, so our rule could look like this. Y equals 3 times X. Like, do you agree that we're taking the X times 3? Because 1 times 3 is this, right? 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So if we had 5 for X, we could just fill in 5 in place of X. So 3 times 5, 15, okay? So once you know the rule, it's easy to find the output if you have the input. Are you with me so far? Any questions? Now, I purposely made this table pretty close to this table. I want you to tell me any differences that you notice or similarities, either one. Eli? Yeah, good. They're all 1. The Y values are all 1 more than what they are over here, right? Like 1 is 1 more than 0. 4 is 1 more than 3. 7 is 1 more than 6. So something that the last class pointed out too that they noticed in the Y's that you add 3 every time, right? Like 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15, right? It's actually the same pattern here because 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10, right? 10 plus 13 plus 3 is 13. So what do you think the next number should be here if it's adding 3 every time, Kevin? Should probably be 16. Okay, we'll check that later. So guys, look, remember how this one was y equals 3 times x? This one's also actually going to be y equals 3 times x. It's just like Eli said, it's one more though, right? So like if I take 2 and I fill it in, you can check 3 times 2 is 6, but I have to add one more to make it equal 7, right? So it's not just times 3 this time, it's times 3 plus 1. So now let's go and fill in 5 for x. And remember, Gavin guessed that it was going to be 16. He's right, because 3 times 5 is only 15, but once we add that 1, it's going to become 16, okay? So now I want you to compare this rule with this one. This one we call direct variation. We're going to be learning about something called direct variation today, okay? So one way to kind of think about it is, in this one, you just take the x and you multiply it by 3. Like you're not doing anything else to it, right? It's like a one-step equation. This one is more like 2 steps because you have to take the x times 3, but then you also have to add 1 afterwards. So again, when it's 2 steps like that, it's not going to be direct variation. This is an example of direct variation. Also, another important thing I want you to notice, see how this has the point 0, 0 in it? Like if we graphed it, it would go through the origin, right? This one doesn't have that. That's another important characteristic we're going to learn about direct variation in a minute here, that it will always go through the origin, okay? Like, do you guys remember y equals mx plus b that we've been learning about? Here, b is 1, right? Like the y-intercept is 1. Here, see how it doesn't say plus anything? That means it's like a plus 0. The y-intercept is 0, okay? That's going to be, again, an important thing to notice about direct variation. So tell the slope and the y-intercept of each line. If we're going to think about that, this is review right now, okay? Quick review. Remember how m stands for the slope in this formula and b stands for the y-intercept? So I'm going to pick a random person. I want to know what's the slope of this line. Let's go with Madeline. What's the slope? Yep, because remember, all we got to do is look for m stands for the slope. So the slope is 3. Ranveer, what would be the y-intercept? Yep, because b is the y-intercept. Okay, remember when y wasn't alone, then it was harder. We had to get it alone before we could tell the slope and y-intercept. But this one's easy because y is already by itself. Okay, how about this one over here? What would be the slope for this one here, do we think? Jackson, what do you think? -2, because it's just a number in front of x, right? So what do we think the y-intercept would be for this one? Anybody have a thought? Eli? It is. So again, guys, if it doesn't say plus anything, it means that it's 0. We have to understand that because when you add 0 to something, it doesn't change anything, right? So normally it will not say plus 0, but you have to know that that's what it means when it doesn't say plus anything, okay? Again, in a minute, we're going to learn how this is an example of what we call direct variation. Anytime the y-intercept is equal to 0. This one would not be direct variation because the y-intercept on that one was -9, okay? So on this slide, we're going to have a definition of what direct variation is, and it looks kind of long and scary, but I want you to kind of circle and underline the important parts with me right now, okay? You know how we've been studying the formula y equals mx plus b. Well, again, in direct variation, b is always going to be 0, which means the equation is just going to look like this. Instead, I want you to circle that in your notes. Basically, we're going to need to memorize that, just like hopefully you memorize that slope-intercept form is y equals mx plus b. We want to memorize that direct variation is just y equals mx because b is 0, okay? So that's another thing that's important to underline here, that the y-intercept will always be 0, okay? M still stands for the slope, but we also call it the constant of variation in this case. I want to kind of tell you why real quick back on this slide. Remember how all we were doing to get from here to here is multiplying by 3. That's it. That 3 is called the constant of variation, okay? This one's a little bit different because not only were we multiplying by 3, we're also adding 1. So we don't really call it the constant of variation in that situation because it's not direct variation, okay? So there's a variety of different questions I could ask you concerning direct variation. Here's the first type. Tell whether the equation represents direct variation. So the formula for direct variation that we just had a definition of about looks like this. So there's no plus anything because B is 0, okay? So basically, if we have to tell whether it represents direct variation, it's like asking me to, it's like me telling you, does it look like this or not, okay? So first of all, in order to answer that, we would need to have y alone because this formula has y alone. So let's circle y. How would I get y alone in this formula? What do you think, Elise? Yep, we're going to take away 3x because 3 minus 3 is 0. Now, normally we write it just in this order, -2 minus 3x, but normally like y equals mx plus b, we've been practicing how the x term comes first, then the -2. Okay, now again, basically I'm asking you, does this look like this? So give me a thumbs up if it does, thumbs down if it doesn't. What do we think? Is it direct variation or not? Somebody who gave me a thumbs down, why is it not direct variation? The y-intercept is -2. The y-intercept has to be 0, right? Remember, this is like a plus 0 when there's no number there. So this is not direct variation because of this guy right here. It would have to be, the y-intercept has to be 0 to be direct variation. Okay, how do we get y alone in this one? Graham, what would I do to get y alone? That's a good thought because we subtracted the x on the other one, but in this one, the y is almost alone. I would just have to get rid of that 1.3, right? Because we can put our dot in there if we want to. Opposite of multiplication's division, right? Anything divided by itself is 1. Now, I know that's a little weird because the y is on the right side, but that's okay. We'll talk about that in a second. We're used to it being on the left side, right? That's okay. The goal is to still get y alone. So let's go punch this in our calculator. What do we get for 6.5 divided by 1.3? What did somebody get for that, Elise? Yeah, and then don't lose your x with it. So guys, I mean, we can just flip it. We can just put the y on this side of the equals and the 5x. That's okay to do, okay? Yeah, just put on my desk so I know to charge it. So give me a thumbs up if you think that's direct variation and a thumbs down if you think it's not direct variation. Like, does it fit our definition of direct variation or does it not? It does, because direct variation basically is just the y-intercept has to be 0, and this would be like a plus 0 because there's no number written for b. So it just looks like y equals mx since b is 0. So this one is yes, this time it is direct variation. Now look, if it is direct variation, there's another part to the question. We're supposed to name the constant of variation. Guys, the constant of variation is just the slope. So 5 in other words, okay? So we would say that the constant of variation is 5. So you might want to add that to your notes, or let's see if it was on this slide. Yeah, the m is the constant of variation. So we might want to add for ourselves here, go back to your definition slide, that it's still just the slope, okay? M stands for slope in this formula, just like it does in y equals mx plus b. Any questions on that type of a problem at all? Being able to tell whether something's direct variation or not when you're looking at the equation. Any questions on that? Okay, remember, there's going to be a variety of different types of questions we can answer about direct variation. Here's the second type of question we might see. It says, graph the direct variation equation. Like it's already telling us that it's direct variation, but direct variation looks like this. It has y alone. So we got to get rid of this 4 first. 4 divided by 4 is 1, right? So we got to go and do 5 divided by 4 on our calculator. Go ahead and do that. You should get 1.25. I don't want a decimal, math bracket, because guess what? That's our slope, right? That's our m. What's my y-intercept? 0. Yes, it's all, when it's direct variation, it's always going to have a y-intercept of 0. So the origin, okay? Again, you can physically add in that plus 0 if you really want to, but direct variation is always going to have a y-intercept of 0. Now, guys, we're used to doing rise over run. That's the same thing we're going to do here. But do you see that the scale is going by 2's on both axes? Everybody see that? So if we're going to count a rise of 5 and a run of 4, we're going to have to be careful, because up 5 from here would be like 1, 2, 3, 4, 5, right? And right 4 would be 1, 2, 3, 4. So right here at 4, 5 would be your point. So you can check and see if you counted the rise over run correctly. Your second point should be at 4, 5. Okay, so again, we just have to be careful when we're counting rise over run when the scale is not going by ones on the grid. Does that make sense to everybody? Any questions on that? Okay, so make sure we're taking good notes, because again, lots of different types of problems, and tomorrow you're going to have an assignment, so we got to know how to do all these different types. Okay, so on the last one, I gave you a direct variation equation and we had to graph it. This time, it says the graph of a direct variation equation is shown. Use the graph to find the equation of the line. So guys, whenever it says direct variation, the first thing I want you to do is write the formula, y equals mx. Remember, it's like mx plus 0, like b is always 0 when it's direct variation, which you can see by looking at your graph. There we go. It goes through the y-axis at 0, right? So to write the equation, we already know the y-intercept 0. We don't have to write plus 0 here, right? But we don't know the slope yet. We got to figure out the rise over run. So look at your other point on the line here. Okay. Remember, guys, sometimes people think of this as the starting point, but we don't want to count left. So don't do it that way. You're going to have to start with this point and count to the other one. So I'm going to give you a minute to do that. I want to know what you get for the rise over run. Raise your hand when you have the answer for that. Anybody have it yet? All right, let's see here. We're rising 1, 2, 3, because the scale's just going by ones this time. And then 1, 2, 3, 4, 5. So 3 over 5 positive, right? Because it's going up 3 and right 5. So again, that number's our m. So our equation is going to look like y equals 3 over 5x. Is everybody good with how I came up with that equation? Any questions? So now there's a second part to the question. It says, find the value of y when x is 10. How would I do that? How would I find out what y is when x is 10? Now that I have an equation, I can just fill in 10 for x. So I can take 3/5 times 10. That way I can figure out when x is 10, what is y. Go ahead and do that math and see what you get. You should get 6. Okay, moving on to another type of question you might see. So guys, this one, we had to write the equation when we were given a picture. Those ones are probably a little easier because you can just count the rise over the run to figure out what m is. This time, we have to write the direct variation equation, but we don't have a picture this time. So again, the first thing I want you guys to do, though, whenever it says direct variation, is I want you to write y equals mx. No plus b, right? Because what's b again when it's direct variation? 0 all the time. It's silly to write plus 0. So we just write y equals mx, because when you add 0 to something, it doesn't change. So guys, this time to find out m, again, remember in this one, we could just count the rise over the run to find m. If we don't have a picture, we can't do that. This time we're going to take, this is like an ordered pair. When x is 13, y is 26. Like remember back on this one, how we knew when x was 10, we could fill it in to find y. Well, this is like backwards, because this time we know x and y, but we don't know m. So what we're going to do is we're going to fill in 13 for x, and we're going to fill in 26 for y. So it's going to look something like this. Everybody with me that all I did was fill in 13 for x and 26 for y? We're all taking great notes right now. How will I solve this for m? Because m is the only thing missing. So how could I solve it to figure out what m is? This means multiplication, right? Let's put our dot in there if we need to. So we're going to divide. Yep. 13 divided by 13 is 1. That's going to get m alone. 26 divided by 13 is 2. Guys, what does m stand for again? The slope. Does the question say find the slope? So we're not done yet, okay? Because the question said write the equation. That means our answer has to look something like this. But now that we know the slope, we can fill it in. So our actual answer is this. Like some people make the mistake of thinking that 2 is the answer. 2 is just the slope. It's not the equation, okay? Because I'm going to teach you a way to check your answer. If we think the answer is y equals 2x, let's go plug it in our calculator. Let's put in y equals 2x. And let's go to the table. Remember the information it gave us at the beginning of the question? It told us when x is 13, y is 26. So let's make sure that point's actually in our table. Right here we have when x is 13, y is 26. So we know for sure that this equation is correct. And another thing, guys, if you check, it does go through the point 0, 0, too. Remember, the y-intercept always has to be 0 when it's direct variation. So we know for sure that that equation y equals 2x is correct. Do you have any questions on that example? So listen, now that I did one, these are side by side. You have another one exactly like it. You're going to do this one on your own now, okay? I'm going to give you a minute to do that. So if we take the formula for direct variation, y equals mx, and we fill in that we know when y is -9, x is 45, then that will let us be able to figure out m, the slope. So opposite of multiplication, we're just going to have to divide by 45. So -9 divided by 45, make sure you do it in that order, okay? It's a decimal, -0.2. Even if it's a nice decimal, I want a fraction. So you need a math bracket because that's our what? What did we just find again? But what does m stand for? The slope, okay? So that is not the answer. Look, the question doesn't say find the slope. It says write the equation. Our final answer has to look like this. So we know m now, the slope, right? So we can fill in -1/5 x. Just like I showed you on the last one, guys, we could, if we wanted to, I would do this if it were a quiz. I would go in and type -1/5 x and go look at my table and scroll down and see if the table has in it the point that it gave us. 45, -9. When x is 45, y has to be -9. Yeah, you'll have to scroll down a little ways to get there, but to me, that'd be worth the time if it were a quiz to check my work and make sure I got this right, okay? Any questions on that type of a problem at all? Okay, another type, you might have a table and it might say, tell whether the table represents direct variation. I want to go back to the very beginning of class when I gave you two tables today. Remember how we said this one was direct variation and the other one wasn't? Because in direct variation, you're just taking this number times something to get this. There's not anything added on because it's like a plus zero, right? When you add zero to something, it doesn't change it. So that's kind of the idea of what we need to look for here. Like, what do you multiply this by to get this? Or the other way to think of it is really what we just did on the last slide. We can kind of write out y equals mx again, but just take 1 point at a time. That means like when y is -2, it tells us x is -5. So I want you to notice what we're doing. Just like the last slide, we're going to divide, okay? Make sure you're still taking good notes. Go ahead and do -2 divided by -5. You're going to get 0.4, but I want you to math frac it, okay? So listen, guys, I'm going to teach you a shortcut. We have to check if I use the next point now. So like 3 and 1.2, watch. I don't need to every single time fill in 1.2, fill in the y here and fill in the x here, because look for patterns. Look what I'm doing to solve this every time. I'm dividing the y by the x, right? Because you're trying to figure out what times this gives you this. So it's just like going backwards, taking -2 divided by -5. We did on the first one, right? This one we're doing 1.2 divided by 3. It's going to be 2/5 again. So let's just do that for all of them. -0.8 divided by -2. Go punch that in your calculator. I'm going to wait till I see 15 hands in the air because everybody should be able to punch numbers on their calculator. So again, I'm doing the y divided by the x every time. Eli? -0.8 divided by -2. We should once again get 0.4 or 2/5. Did everybody get that? If we math frac it, then 4 divided by 10 we got to do. What do we get for that one? Should get 2/5 again. And the last one, 8 divided by 20. Because again, guys, look, you're always dividing the y by the x. Should be the same thing again. Guys, that number is called the constant of variation. Like in direct variation in this formula, y equals mx, that number is your m. You're going to fill in 2/5 to write your equation, okay? So that's our answer. Again, if we really wanted to check our work, we could go type this in y equals in our calculator and go look at the table and see if it's the same as this table. And it would be, because this equation works for all of the points, okay? So then we're going to do one more like that, but you're going to try it yourself this time. So think about what we did on the last one. Because the equation for direct variation looks like this, and you're always putting the y here and the x here, what you're really just doing to solve for this is you're dividing by -0.2, right? Like you're taking the y divided by the x every time. So go ahead and do that. But I want you to do it for all the points. Like when you divide the y by the x, do you get the same thing every time? That's what I want you to figure out. Okay, let's see. That one, 30 divided by -0.2, you should have gotten 150. So if we take the y divided by the x here, you're going to get -1.5 or -3/2. Not the same thing, okay? So guys, really, we could do y divided by x for all the rest of them, but we don't really need to waste our time, because if they're already not the same, then it's not direct variation. Because again, if we go back to the last one, that constant of variation is what it's called. That 2/5 that we got every single time, that's what makes it direct variation. We didn't get the same thing this time, so it's not direct variation. Okay, questions on that one at all? All right, We're going to do another graph. We did one earlier. It says graph the direct variation function. So again, if you see the words direct variation, guys, the first thing I want you to do is write this on your paper every single time. And we know, what's the y-intercept going to be if it's direct variation? 0. Good, because it's like this. Okay, so we already know that. We could go ahead and graph our y-intercept already if we want to. But then, guys, y has to be alone, right? We got to get rid of this 8. But, guys, I want you to put a 1 in here. That's so important because otherwise you're not going to know what numbers you're supposed to be dividing. So 1 divided by 8 is what we have to do in that order. Order of division is very important. So you're going to get 0.125. I don't want a decimal because that's my slope. I need a math bracket, 1/8. So y equals 1/8 x. Again, it's like a plus 0. B is 0. Okay, so we'll start at 0. My rise over run, I'm going to go up only 1 and go to the right 8. So this is going to be a very not steep line. Like it's almost horizontal, because remember how a horizontal line has a slope of 0? Well, 1/8 is really close to 0 because look what it was as a decimal, 0.125. It's a really small number. Remember I taught you on the first day of the chapter, the bigger the slope is, the steeper the line's going to be, right? The closer it is to 0, it's not going to be very steep. It's almost horizontal, okay? Questions on that one at all? So again, tomorrow when you have an assignment, you'll know that when you have to graph direct variation, hopefully the y-intercept is always 0. I hope you remember. And then you just use your slope, your rise over run to find another point. Okay. All right. We're going to finish with a story problem. So the amount of time, t in seconds, it takes to download a file varies directly with the size of the file, s, in kilobytes. We're going to stop right there for a second. Let's read that one more time. The amount of time, I want you to circle that it takes to download a file varies directly, I want you to underline that, with the size of the file. Let's stop and think about real life for a second. Have you ever downloaded a picture or some kind of file on your phone or on your computer? The bigger the file is, the longer it takes to download usually, right? So that's why when it says the time, normally when we use direct variation, our equation looks like this, right? But it says the time, t, so it doesn't want us to use y, varies directly with the size, s. So just instead of using y equals mx, we're using t equals ms, okay? But because it says it varies directly, that's why we know it's going to look something like that when we write our equation in a minute here, okay? It also tells us a 420 kilobyte file would take 15 seconds to download. So it wants us to write a direct variation equation that relates t and s. So guys, don't get scared just because this is a story problem. This is exactly what we did back on number 6. Remember how we had an x and y value and we filled them in so that we could find m, the slope or constant of variation? Well, we have that here. We know that when the size of the file is 420 kilobytes, we know the time that it will take, right? So we just have to be careful that we're putting 15 in place of t because that's the dependent variable. The time depends on how big your file is, right? Like the 420 is the size. We need to put that in place of s, okay? Does that setup make sense to everybody? Do you have questions on that? Then again, it's just like number 6. If we want to solve this for m, opposite of multiplication, we're just going to divide by 420. So you do that. Tell me what you're going to get when you, for m, when you do 15 divided by 420 in that order. Ryan? Almost. I think you did it in the wrong order. We have to make sure we do 15 divided by 420 in that order. And we're going to need a math frac that gross decimal. So it's 1 over 28, 1/28. Not at all. Okay. once again, guys, you got to keep track of what you're finding. That's just the slope. That's not the equation yet. Remember, our equation's going to look like this. So now we can fill in, though. We just found out that m, the slope, was 1/28. So here's our equation. Okay, everybody with me? Now, it's helpful to find the equation because now I could figure out any size file. Like if I have an 840 kilobyte file, I can figure out how much time it's going to take me to download that by just using my equation. But I would have to be careful. This is the size of the file, right? Like we would make sure we want to fill that in for S. So we would do 1/28 times 840. That math will help us figure out what's the time. How long is it going to take us? So 1/28 times 840. See what you're going to get for that. Anybody have it yet? 1/28 times 840, Elise? Yep, and it's the time in, go back to your directions, seconds, right? We should label when it says story problem. It's going to take us 30 seconds if we have to download an 840 kilobyte file. Guys, also you can think about how that makes sense because we started with a 420 kilobyte file and that took 15 seconds. This is twice as big and it's going to take twice as long to download, okay?